Welcome back, everybody. In the Wolff Kishner reaction, we react this chemical called hydrazine with the ketone. In the first step, we attack the ketone and we make this intermediate. And this O minus cannot reach that H. We have to show we know that. We say the O minus from one molecule grabs the H from another one, and we add this word to show we know that. Without that word, you lose a point. Intermole means transfer between two different molecules. Remember, we're using an amine that is closer, hydrazine is most closely represented by a primary amine. So our goal is to make an imine. IM. And what happens here is we push off hydroxide. We generate this species here. I know my nitrogen changed color. We also generated hydroxide. And our imine is almost ready. I want to show everything on the screen. This is the conjugate acid of the imine. And we got to go a couple more steps. And we're going to need more hydroxide. There is excess hydroxide. And you noticed we haven't had to use hydroxide yet. We made a hydroxide and then used it. Right now we're going to use the excess hydroxide. Hydroxide 1 catalyzes what we call a tautomerization. We've seen several of those in the two classes. Don't forget your formal charge. Don't throw away a half point. Tautomerization, grab sigma, make pi, protonate a pi bond. So you're making a new pi bond and protonating an old pi bond. So here's one of the H's. You need 2 new H's when you're done. And there's one of them. And we still have a nitrogen attached. And we lost an ethyl. There we go. Sorry, my ethyl moved a little bit. That N has a double bond to N now. And still has one bond to H. And somehow we got to make that into these two things. And we use a base again, hydroxide. And its conjugate acid provides the proton just like it did in the previous step. Conjugate acid right here provided a proton for the tautomerization. Conjugate acid here. The water is going to provide a proton for what looks like a tautomerization, but we're doing an elimination. So you're going to end up with N triple bond to N. The single bond between N and C becomes a single bond between C and H, and hydroxide catalyst is regenerated. So the role of hydroxide was always as a catalyst. We used hydroxide here, and we made it later. Oh, we made hydroxide here and used it. So catalyst, use hydroxide here and make it, use hydroxide here and make hydroxide. So hydroxide was a catalyst 3 different times. And that's the Wolff Kishner. How are we doing on time? 4:24 to 5. We got 4 pages to go. There's a short form for this mechanism you'll see on study guides. And the short form is worth the full points too, where you can combine steps. But I'm going to avoid combining steps today. And moving on, looking ahead. This is a definite new topic, spectroscopy question coming up here. So quick break, and then we come back to this one. This one won't be long at all.